All right, so let's talk about mid-range. So mid-range is one of the measures of central tendency. So it's an estimate, a very quick and rough estimate of the middle of a data set. And it's found by adding the lowest and highest values and dividing by 2. So really simple calculation. So let's do an example. So recalling from earlier examples, we have this tornado archive in Lansing State Journal, and this is a list of number of tornadoes in Michigan each year from 2014 to 2021. What is the mid-range? So to find the mid-range, we just need to identify the low value. So it looks like the low value was 3, and the high value was 18 rather. So what we're going to do is we're going to add those up. So I take 3 and I add 18 and then I divide by 2. The other way you could write it is parentheses 3 plus 18 divided by 2. If you want to enter it all into your calculator at once, I would do it that way. So I'd either do 3 plus 18 enter divided by 2 or parentheses 3 plus 18 and then divided by 2. So either way works. And so we get a mid-range of 10.5. And so that's just a quick rough estimate of the middle around the list of number of tornadoes in Michigan each year from 2014 and 2021. One last thing I want to mention, since we're wrapping up these videos on measures of central tendency, is the idea of outliers and how that affects these measures of central tendency. So we've learned about 4 measures of central tendency. Well, there are 4. So mean, median, mode, and mid-range. And these are all estimates of what's typical. So estimates of a typical value in a data set. And when we have an outlier, so an outlier is a data value that we consider extreme. So compared to the rest of the values in the data set. So it could be on the low end, low extreme, or it could be very high on the high extreme. But it's just outside of, what you consider typically normal in your data set. And so outliers are going to make a particularly big impact on some measures of central tendency, and then others it's not going to matter at all. So there are actually 2 measures of central tendency where outliers are going to make an impact, and that's with mean and that's with mid-range. And if you think about it, with mean, you have to take the sum of all values divided by the number of values. And so if you have a value that's really high or really low, that's going to be factored in the sum. So it's going to impact the mean, or the average, that we are considering calling by mean. And then with mid-range, we're going to take the low plus high value and divide by 2. And so if you have an extremely low or high outlier, those are going to be considered the low or high value, and that's going to factor into that formula. The other 2, so median and mode, these are resistant to outliers. Because if you think about the median is the middle. So if you have some numbers here, I'm just going to make up a data set. And let's say we have this data set and the median, the middle number is 4. Well, I could add some outliers. Let's say I add a 1 on this side, which wouldn't be an outlier, and then maybe I added a 100,000 on this side. If we do that, we see that 4 is still the middle. And so it's resistant to those outliers. Those outliers don't affect that median. And the same is true for mode. I could take a list like this, and maybe I have a 4, a 4, a 4, a 5, and a 10, and a 3, and a 2. And I could say, okay, well, the mode right now is 4 because it occurs 3 times. I could add 100,000 on this end, or maybe I could add a negative 1 million on the low end, and it doesn't matter because the mode is still 4. So it's just nice to know, because sometimes it's nice that we have all of these different options, because sometimes one measure of central tendency might not give us the best picture, and we want to use a couple of them together to get a good sense of our data set.